The first thing we want to do when we're graphing this rational function is we want to factor it so we can see what factors are involved. So in this case here, I factored it and we have a common x minus 1 factor in top and bottom. So that's going to generate a hole at x equals 1. And we might as well find out the y coordinate here. So as I plug in x equals 1, I get y equals 10 over 7. So I'm going to put that into our table of values here. At x equals 1, we're going to have a coordinate at 10 over 7, about 1 point, looks like about 1.4. So that's the first thing we're going to do. We also have a vertical asymptote at x equals -6. So I'm going to put my vertical asymptote in here, my table of values, so -6. So on my graph then, at -6, maybe somewhere around here, I'm going to have my vertical asymptote show up. We also have zeros. Zeros are going to show up at x equals 0 and y equals 0. We also have one at -7 over 3. So I'm just going to move these coordinates over a little bit. So -7 over 3. We have a 0, and I'm just going to put my vertical asymptote in here like that. Now I'm not going to put these coordinates in yet because they're a little bit hard to work out. But we've got coordinates here like this. I've got my vertical asymptote. I want to get my slant asymptote, so I'm going to do my long division here. So doing my long division, I'm going to divide the x plus 6 into 3x squared plus 7x. So I multiply by 3x. So then -11. So I have a remainder of 66. So my slant asymptote is going to have a y-intercept at about -11, so maybe somewhere around here. And it's going to have a slope of -3. It's going to have a slope of 3. So it's kind of a little bit hard to do here, but looks like maybe something, a slope, maybe something in this order. Okay, so it looks like based on the coordinates that we have so far, we can see that it's going to follow the asymptotes, go through those zeros, follow the asymptote here, and then we're going to have some part in here, which we'll figure out. So there's going to be some min and maxes that we have to figure out. So I'm going to find my derivative. So working out the derivative of this, so f prime, when I differentiate the numerator, I'm going to end up with, and I'm going to differentiate 3x squared plus 7, so I'm going to end up with 6x plus 7 times the denominator x plus 6 minus 3x squared plus 7x times the derivative of the denominator, which is 1. And then I'm going to have it all over x plus 6 all squared. Expanding this out, I get 6x squared plus, it looks like 36 and 7, so 43x plus 42 minus 3x squared minus 7x. So combining the like terms, I end up with 3x squared plus 36x plus 42, factor out the 3, I end up with 3x squared plus 12x plus 14, and we're going to make that part equal to 0. Okay, so I do have my vertical asymptote still at -6. Okay, so this is my f prime values that I'm going to work out. So I need to first of all figure out the zeros of this. This is not factorable. So I'm going to use the quadratic formula to find my zeros. So I'm going to maybe do that down here. So x is equal to negative 12 plus minus the square root of 12 squared minus 4 times a times c. And that's all over 2a, which is just 2. So simplifying this, I get negative 12 plus minus the square root of 88 over 2. This works out to be negative 6 plus minus root 22. Okay, so this works out, the x value here, the two x values are going to be x equals, the decimal value is going to be negative 1.31, so that's going to be negative 6 plus root 22. And then the y coordinate, when I plug this into the original equation, I get negative 0.86. Okay, so that's going to be some coordinate in here. Okay, that's going to be the min point, and it's kind of hard to draw in here because it's really close to the x-axis, but there it is, right? Somewhere kind of in there. And then the other coordinate, when I solve for x minus root 22, I get negative 10.69. And I get a y coordinate of about negative 57.14. So it's way down there. So negative 10.69, maybe somewhere around here. Okay, so that's going to be about negative 57. So that works out to be, looks like it's going to be a max. So this is negative 6 minus root 22. There's my zero slope. And I also get a point here at negative 6 plus root 22. I get a zero slope. I'm going to do my slope test. So I want some, plug in some slope values here. F prime at negative, let's put in negative 11, for example. Putting that into my derivative, I get 11 squared. That's going to be positive 121. Plus or minus is going to be 11 times 12. So that's going to be negative 132 plus 14. That's going to give me a positive value. So it's going to give me positive slope through here, a zero slope. I'm going to choose some point in between negative 10 and negative 6. So maybe negative 7. Plugging that in, I'm going to end up with 49 minus 84 plus 14 in the numerator. The denominator is always positive, so I'm just going to work out the sign as negative. Okay, picking out a point between negative 6 and negative 1.3, so maybe we'll choose f prime at negative 2. That works out to be, it looks like it's going to be negative, so it's going to be pointing down here and then across. We kind of already know that that's the shape. And then f prime at 0, we're going to end up with positive, so it's going to slope up through here. Okay, so there's my slope charts. There's the points I have. There's my min and max points here. I'm going to follow the graph, follow the asymptotes. That's my maximum. I'm going to go down to the vertical asymptote here. On the top part, it's going to follow here, go through the zeros, hit the minimum point, and then follow the asymptote up here. So we're going to get a graph that looks something like that.